Find theta between 0 degrees and 360 degrees satisfying cosine of theta equals -2/5. In the interval between 0 and 360 degrees, there should be two theta that satisfy this equation. -2/5 is not the special number, so we would use the inverse trigonometric function, which states that cosine inverse of -2/5 equals theta. We then use the calculator to find out what theta is. Theta is 113.58 degrees. If we round it to one decimal place, then this would simply be theta equals 113.6 degrees. But before we find another angle, keep in mind that if we were to use cosine inverse, then we need to restrict our domain into the first and the second quadrant only, from 0 degrees to 180 degrees. That is why when we use cosine inverse, we only obtain one number in this interval from 0 to 180 degrees. There is another angle that would give us cosine of theta equals -2/5, and that angle is in the third quadrant. Theta equals 113.6 degrees is an angle in the second quadrant. But there is another angle in the third quadrant as well that will give us the same cosine of theta. This second angle that we're looking for is not in the restricted domain. And so, to find out what this second angle is, there's a few things we can do. We can either find the reference angle from 113.6 degrees, which is the little angles here, and then add it to 180. This is 180 minus 113.6. We'll get 66.4 degrees. And again, this is this angle from 113.6 to 180. To obtain the second angle, we would take 180 degrees plus 66.4 degrees, which is 246.4 degrees. We can check with the calculator that cosine of 113.6 degrees will give us the same values as cosine of 246.4 degrees, and we will roughly get -0.4 in the calculator. -0.4 is -2/5. We won't get exactly -0.4 because we rounded the angles. And again, this second angle, 246.4 degrees, is not in the restricted domain, but we use it because in the given equation, there was no mention of cosine inverse at all. We only use the cosine inverse as a tool to solve the problem. If the question simply asks us to find cosine inverse of -2/5, then the only answer is 113.6 degrees and we are done. But the question asks us to find the angle between 0 and 360 degrees as long as the angle satisfies this condition. And we found two in this case. Similarly, for tangent of theta equals 5, there should be two angles that satisfy this condition. 5 is not one of those special ratio, so we would use inverse tangent. Tangent inverse of 5 equals theta. We use the calculator to obtain theta, which is 78.69. Rounded to one decimal place, this is 78.7 degrees. This angle is in the first quadrant, and tangent is positive in the first and the third quadrant. And so we will obtain another angle if we add another 180 degrees to the first angle that we found, which is 78.7 degrees. The second angle is 78.7 degrees plus 180 degrees, which is 258.7 degrees. We can check that tangent of 78.7 degrees equals tangent of 258.7 degrees, and both of these are equal to almost 5. And again, we won't get exactly 5 because we rounded the numbers here. In this case, when we use tangent inverse, we should restrict our domain in the interval negative pi over 2 to pi over 2, but we use an angle 258.7 degrees that is not in the restricted domain because we only use tangent inverse as a tool to solve this equation. The given equation or the problem does not mention anything about the tangent inverse. If the question asks us to find tangent inverse of 5, then the only answer is 78.7 degrees, and we would have been done. In this case, we found two angles that satisfy this condition.